Okay, so every triangle has 3 angles. I'll just call them angles 1, 2, and 3. All right, so we already discussed yesterday, sometimes they'll all be acute, sometimes you might have one that's right, sometimes you might have one that's obtuse. We discussed yesterday how you can only ever have at most 1 right angle. You couldn't have 2 right angles. Same thing with obtuse angles. You could only ever have 1 obtuse angle. You couldn't have 2 obtuse angles in the same triangle. And you also can't have 1 obtuse and 1 right. That's impossible. So every single triangle will always have at least 2 angles that are acute, all of them. It's just what's happening with that third angle. Maybe it's also acute, maybe it's right, or maybe it's obtuse. Those are basically your 3 options. So every triangle is going to have 2 acutes and then 1 that could be any of the 3. All right, but what is true about the 3 angles in a triangle, no matter what kind of triangle it looks like, it doesn't matter, they all add up to the same thing. Does anybody know what the 3 angles in a triangle add up to be? You're going to have to say it out loud since we don't have the chat anymore. Three angles in a triangle. What do they add up to be? Take a guess. Okay, why don't
180.
Oh, thank you. 180 I got. Yes, it is 180. Why in the world is it 180? Why would this angle plus this angle plus this angle always add up to be 180? That seems strange. Like, sure, maybe there's one triangle where that works, but you mean to tell me every single triangle? You mean to tell me that even a triangle like this, that's a right triangle, if I add up these 3 angles, they're going to add up to be 180? Yes, I do mean that. Any triangle, I don't care what your triangle looks like. If it's a triangle and it has 3 angles, which obviously it would, if you add the 3 angles together, it will always add up to be 180. I know it seems impossible. I'm going to show you why this works. So give me a second. First, let's put in our notes a big star because this is the most important takeaway from today. The sum of the 3 angles in any triangle is always 180 degrees. Always, always, always. There are no exceptions to this. You take the 3 angles inside the triangle, you add them together, you will always get 180. So I have a little demonstration to show you why this is. So let me give you a minute to jot this down, and then I will show you. Those of you that are in class, I would make sure that you are logged into the Zoom if you aren't already. So that way you can see these, you'll be able to see it on your screen a lot better up close than it up on the board. Okay, so assuming everybody has this written down, I got to share a different screen with you. So give me 1 second to do that. All right, so let me share this. Okay, so let's take a look at what I have here. So hopefully you can see this. So what I'm given is a triangle, Okay, and what they have done, they just made some random triangle and they took a line and they just drew it through one of the sides. So see this line right here, IJ? See that kind of gray line that's extending? So they did that. They have a line, they just took a side and made it kind of long. Then what they have done is they've drawn a line parallel to that one that hits through the third point of the triangle. Okay, and you can do this with any triangle. So you start off, you just take one side and you make it super long, and then the vertex that you haven't crossed through, you're going to cross through that one. Just make sure that your line is parallel to the original one. Okay, now I'm going to prove to you that the sum of the 3 angles inside of this triangle are going to add up to be 180. This is so cool. So watch this. They're kind of asking me the questions down here. They're asking me the measure of triangle I'm sorry, not triangle, angle HIJ. Hang on, I meant to sign in with my iPad and I forgot. Give me 1 second. We're in B block. There we go. Okay, so they're asking me about the measure of angle HIJ. So here's angle HIJ right here. HIJ, where are you? Oh, right here. So that's the one that's marked 53. They're asking me what angle is that going to be congruent to? So if I pull this pull down thing, you'll see there are my options here, right? So this angle that's marked 53, I got to pick which of these 4 angles it's equal to. So, well, let's see. If I have parallel lines and here's a transversal, wouldn't the alternate interiors be the same? Right? Do you see that? So those alternate interiors are going to match. So that means that HIJ, this angle right here, is going to match up with this one right here, which is what? IHK. So let's pick IHK. And why are they equal? Because we said that they were alternate interior angles. Now watch this, okay? Are you watching? Watch what this thing does. This is so cool. Oh, do you see that? How neat. So these 2 angles that are alternate interiors are going to be equal to each other. Both going to be 53. Okay, so I have those 2 that match. Now it's asking me a different question. Now it's asking me about angle IJH and who is that equal to? So first of all, let's look at who even is angle IJH. Okay, that's this one over here that's marked 43. So who will this angle be equal to? Well, if I do the same thing, here's my parallel lines, and now here's the transversal that I'm looking at. So one angle that's going to be equal to that one would be this one right here, because that's another pair of alternate interiors. So what's the name of that angle? JHL, looks like. So let's look in the drop-down menu. Yep, there it is, JHL. So those 2 angles are going to be equal because, again, they're alternate interiors. All right, so let's see what happens when I click try here. You see that? So there's another pair of alternate interiors. So now look at what's going on right here. Guys, what do you know about these 3 angles? Someone tell me out loud. What's up with these 3?
They all add up to 180.
Yes, so that's the next thing they're asking me. These 3 angles, IHK, the angle that's marked X, plus JHL, all equal 180. Why though? How did you know that?
Because the line that's there, I guess it goes straight and there's that curve around it, and like, yeah.
That's exactly it. They make a straight line together. So that's even a choice in the drop-down menu. They form a straight line. Yes. Oh my gosh, how cool. So, oh wait, let me clear this. Let's click try and see what happens. Oh, now they just want the value of X. So now if I know that these three angles are going to add up to be 180, I should be able to figure out what X is. So let's see, 43 and 53 is 96. Take that away from 180 and you get 84. So the angle X must be 84 degrees. Let's try it. Okay, so they didn't do anything cool, but now what they want me to do is change the triangle. So now, because I know you might be thinking, well, yeah, okay, great, that worked for this particular triangle, but what happens if you have an obtuse triangle? Is it still going to work? Yes, because watch. Are you watching? Watch. So when I move this, I can change everything. So let me make one of those top angles an obtuse angle. So like this. See that? So I just changed this one. Now I have an obtuse triangle, but all the same rules apply. I still have a pair of alternate interiors here and another pair here. These three angles over here are still going to add up to be 180 because they're always going to make that straight line together. So no matter what kind of triangle I make this look like, I could do it with a right triangle. It doesn't matter. Watch. I'll give it a right triangle. Let's see. There it is, 90. So I still have those pairs of alternate interiors that are going to match. So these three angles are always going to add up to be 180. And this angle always matches that one. And this angle always matches this one. So therefore, what I can say is that even now for all future cases, I don't need to draw these parallel lines. I know that in any triangle, no matter what, if I add the three angles together, it will always be 180. And that's why. Wow. So anyway, I thought that this was so cool, and I love that they took the angles and like made them float around. So let's just say, let's leave it like that. And, oh, okay. I think that's all that I had to do on this. Is it? I don't know. Did I? Well, that's all I wanted to show you anyway. So does that make sense? I hope. Again, the thing that I really need you to take away from this is that all three angles add up to be 180. But I thought some of you would appreciate seeing why they add up to be 180. I think that's so cool. All right, so let me go back to my camera here. All right, so now that we know that that is true and why that's true, let's go ahead and just try some problems with it. So we'll start off easy with just some numbers, and then we'll throw in some algebra. Okay, take a minute and just find me the value of X in each of these. I may call on you at random, so be ready. Actually, I'm going to add a part 2 to this. Not only do I want you to find the value of X, once you have found it, I want you to then classify by angles. So, I mean, for the first one, you're going to figure out what X is, and then I need you to tell me if it's acute, obtuse, right, which type of triangle is it? You don't have to do by sides, just by angles. So your choices would be acute, right, or obtuse. For the whole triangle, not just the angle that you found. The whole triangle. Classify triangle by angles. Okay, ready? I'll take that as a yes. All right, Megan, number one, what is the value of X?
90.
Yes, which means that this triangle is what type of triangle?
A scalene right.
You're right. Yeah, you didn't even have to do the scaling part because I didn't mark any of the sides, but you are right. And you know that it's scaling because none of the angles are the same. So that's something that we'll talk about in a future section. I don't know when, but so if a triangle, fun fact for all of you, if a triangle has two sides the same, then it has two angles the same. If it has three sides the same, it has three angles the same. So if it has no angles the same, then it means it has no sides the same either. So that's one way that you can tell if it's scalene or isosceles, even if the sides aren't marked, you can look at the angles. Okay, number two, what is that one? Juliana, what is the value of X?
60.
Yes, 60. So what kind of a triangle is this?
Acute.
Yes, you could say acute. If you said equiangular, I would take that as well. So acute or equiangular, because this is that weird case where they all happen to be the same. So I would take either of those words, acute or equiangular. All right, number three. What is the value of X in this case? Kira. 150 is correct, which means that this is a what type of triangle?
Obtuse.
Yes. So this has to be an obtuse triangle because I have one that is greater than 90. And in number four, what is the value of X this time? Oh, I don't know. Olivia. I don't know if you.
It cut off.
Oh, I wonder what the value of X is in number four.
Is it 70?
Yes. So what type of triangle must this be? Is it right, acute, or obtuse?
Acute.
Yes.
Acute.
Acute. Perfect. All right, let's step it up a notch because it's not always just going to be numbers. We're going to throw some algebra in there. Okay, you ready? I knew you would be. All right, let's try this. All right, so let's just say I gave you something like I gave you that. I have no idea if this is going to come out nice or not, but. I'm going to let you give this one a shot. So do what you think you should do. You got to solve for X here. Got to be something. This
30.
Oh, I heard 30. Anybody else getting 30?
I got 32.
You got 30 as well?
I'm still doing the math. I got 30.
Okay, I'm hearing a couple of 30s. Let's see. So where in the world is this coming from? Well, remember what our big takeaway is. All three angles add up to be 180 all the time. So that is my equation. So if I have some algebra in here, I need to write an equation, and that's going to be it pretty much every time. I can always add the three angles of a triangle together and set it equal to 180. That is always going to be true. So let's go ahead and do it. In this case, it doesn't matter what order you add them in, right? Because I'm just adding, so you can add in any order you like. Let's say I added these two and then that one. So I would just do 2x plus 5, add to that x minus 5, add to that 90, and all together those three angles should get me to 180 degrees. All right, so now it's just up to me to evaluate this correctly. So if I look at just the left-hand side, I notice I have a plus 5 and a minus 5. They're actually going to cancel each other out, right? Plus 5 and minus 5 just go away. Then I have 2x and x, so together that's 3x plus 90 equals 180. And now I can solve this equation like I always do. Minus the 90. Divide by 3. So yes, those of you that got 30, I agree with you. This is the correct answer. Now you need to be really, really, really careful because I'm thinking of like MCAS or, you know, even like a test or a quiz. They could then go one step further. Instead of just asking you to find the value of X, they might ask you to find the measure of one of these angles, right? Or classify the triangle even further. So be very careful. In this case, all I wanted you to do was solve for X, and you did.
Miss Davy, I have a question.
Yeah.
Sorry, how did you get 90? Like, where did you get 90 from? Oh, wait, no, from the, never mind.
Yeah, no, good question. Yeah, because if that wasn't there, then you, if I didn't put that little box, you could not have done this problem. You'd have no idea. You couldn't go anywhere. You have to have something for all three angles. All right, let's
okay,
try.
thank you.
No problem. Let's try another one. What if this time I gave you, I'm just, also, you never go off of looks, ever, ever, ever. So even if I draw a triangle like that, that looks like that's a 90 right there, if I don't mark it as a 90, you don't know that it is. So in fact, I'm just going to mark it as an X. I have no idea what that's going to come out to be. And let's mark this one as a, let's mark this as a 2X and let's mark this as a 3X. See what happens. So one thing that you want to remember is that nothing is ever drawn to scale. This looks like maybe that's a right angle. Like if I'm just looking at how it's drawn, it's never drawn to scale, especially when I'm drawing it by hand, right? Sometimes the ones on the computer, they say that they're not drawn to scale, but they kind of are. But you can't ever assume that they are. When I'm handwriting it, my gosh. First of all, I know that this isn't to scale because think about whatever X is, that's going to be 3 times as big as this one. So that angle should be 3 times bigger than this one. So I know for sure that this is not drawn to scale. So we always go off of the numbers, not the looks. So I'm going to actually ask you to find the value of X. And then I'm going to ask you to then determine if the triangle is right, obtuse, or acute. So take a minute to do that. So you got to figure out what X is first. Oh, that's funny. X won't always equal the same thing. That just so happened this time. Okay, do we have a value for X yet?
Yeah.
What is it?
It's 30.
Yeah, it just
30.
so happens that this one came out to be 30 as well. They obviously will not always be 30, but I have 3 angles. This time I don't know any of the angles. In the last one, I at least knew one of them, but I don't know any of them here. I'm still just going to add the 3 angles together, whatever they are. Take them, add them all together, and it's always going to equal 180. So in this case, if I just combine my terms, X and 2X and 3X all together, that's going to get me 6X, right? Because that's 1. 1 plus 2 plus 3 gets me 6 X's all together. So I divide by 6, and yes, X just so happens to be 30 again this time. But I'm not done. That's only the first part of this. So cool, I have X, but now I got to figure out the measure of these 3 angles so I know if this triangle is right, obtuse, or acute. So I do know this one's got to be 30 degrees because that's just X. So this is a 30-degree angle. This one here, that's 2X, that's going to be 60, right? Because 2 times 30 means that that's a 60-degree angle. But then this one's going to be 3 times 30. So I actually have a 90-degree angle there. Again, I know it's not drawn like that. Those don't look like those measures. It doesn't matter. We always go off of the numbers. So if I have a triangle with a 30-degree angle, a 60-degree angle, and a 90-degree angle, what type of triangle is it?
A scaling right angle.
Yes, it's a right triangle, and you're right that it's scalene because all 3 angles are different, so all 3 sides must be. So this thing's going to be a right triangle. And you're right, if you want to add scalene, it will be since all 3 angles are different. Cool. Okay, let's try one more. And this time I'm going to so again, I'm just going to give you some random triangle. I don't know. Let's say that this one's, I don't know, 20 degrees. This one's 3x plus 10. And this one's going to be, oh, I don't know. How about x plus 5. I don't know. Who cares? Whatever. So those are my 3. And let's just say if I label these vertices, so I have triangle ABC. Here's your instructions this time. Find the value of X, then find the measure of angle C. So I want to know what angle C ends up being in degrees when you're done. I have no idea if this one ends up working out nicely or not. I don't think it does. Sorry. But you know what? Sometimes we have fractions and decimals. And that's just the way life goes. Not everything is a whole number. It's not that bad. It doesn't come out too terrible. At least it's a nice decimal.
Miss Davia, I have a question.
Yeah.
So once you get your answer right, would you do that like the last question that we did? Like, would you plug it in as X to find C? Okay.
Yep.
Thank you.
You got it. Okay, do people get a value for X? Did it come out as a decimal? Yeah, this one should have. So if I add those three angles together, again, you can add in any order you like. It doesn't really matter. So I'll just do 20 plus 3x plus 10 plus the x plus 5. So you got to add all three together so that equal to 180. Now I'm just going to combine like terms. So if I'm just looking at that left-hand side, I have 3x and x, so that's 4x. And then if I add together 20 and 10 and 5, that's 35. Now we just solve like we always do. So I got to minus that 35 and divide by 4. So that's 145. So 145 divided by 4 just so happens to be 36.25.
That's what I got.
Good. So we got a decimal, no big deal, whatever. Sometimes it's decimals, sometimes it's not, especially when I'm just making up numbers. They can't all come out perfectly. So if I need to now find the value of C, I'm just going to take that 36.25 and I'm going to pop it in right there. So I want to do 3 times that plus 10. So if I do that, I get 118.75. Is that what you got?
I got 118.9.
I wonder if that's just rounding. Did you round it to
Yeah,
30?
I rounded up to 36.3.
Yeah, don't do that.
Okay.
All right. So now if I asked you to classify this triangle as acute, obtuse, or right, you could. It would have to be what?
Obtuse.
Yeah, because I have an obtuse angle, which means that even though I didn't figure out what angle B is, it has to be something that's acute. But that'd be really easy to find. I would just take the 36.25 and add 5 to it, right? So that's just what, 41.25? So yeah, that makes sense that I'd have my 2 acute angles and 1 obtuse. All right, guys. So that's pretty much it as far as what I had to teach you today, I think. Oh, your homework's on CUDA today. Well, that's different. So let me hop on back over there and just take a look at what that. Hold on. All right. Homework 5.2, angles in a triangle. Okay, yeah, this is pretty straightforward, kind of. Oh, yeah. All right. I do want to do just maybe like one or two of the ones at the end because they're just a little bit more involved. So the first bunch is just like we did. So now let's look at, give you some of these ones at the end. Yeah. All right. So let me share this screen with you. All right, so eventually in the homework, you're going to get to suit a couple problems like this, which look like a whole lot's going on at first, but it's actually not as bad as you think. So keep in mind that you have multiple triangles here. There's not just one. So one thing that I always do whenever I'm doing any kind of geometry-ish problem, you don't have to start right here. There's no way that I could figure out what that missing angle is right now because I don't know what this one is. So I couldn't get anywhere. You don't ever have to start. You just start anywhere. So if I'm looking, I notice right here I have a triangle and I have two of the angles. So I can find the third angle in that triangle. So I like to look at a diagram and anything I can find, I'm just going to find it. I don't know if I'm going to need it or not yet. So let's see, if I do 180 and I subtract 49 and 45 from it, that means that that angle right there is going to be an 86. So let me just stick in, that's an 86 right there. And then, what do you know? Check this out. These three angles, don't they have to add up to be 180? Because those three together would make a straight line. So let me do 180 and I'll take away the 86 and the 59. 86 and 59. Yep. So that means this missing angle right here, I just found out is going to be 35. Now I have enough. If I look at this triangle, I have two of it. So 35 and 65 is 100, which means that this angle right here, the one that's missing, must be 80. What fun! Okay, let's do a different style one. This one. Look at what's going on here. I can't find this missing angle yet because I don't know this one. But check this out. Aren't these two angles vertical angles? And won't vertical angles always be equal? They will. So what's so cool about this one is I can look at this triangle and I can say, oh, I can find that missing angle. That's no problem. So let's do 180 minus 22 minus 45. And that means that this angle is 113 right there. Well, if that angle is 113, then this angle is 113 because they're vertical. Gosh, I love how geometry just everything just comes together. So let's take those angles away from 180. I find out that this missing angle must be 24. So I know you probably can't see it on the screen, but there should be a 24 down there. Yep, there it is. Okay, so for some of these towards the end, you just got to get a little creative. Check out this one. So here, oh, you could do this two different ways. This diagram has three triangles in it. Do you see them? You've got one triangle, you've got two triangles, and then the whole big one is a third triangle. So just look at that big triangle. You have two of its angles already. That one's 50, that one's 53. So that means if I do 180 minus 53 minus 50, that means this whole angle right here has to be 77. So if the whole thing is 77 and this little piece is 20, doesn't that mean that this piece has to be 57? You got me? Do you see what's going on here? So that's one way you could have done this one. You could have also started with this little triangle and found this missing angle. And then you can find this missing angle because they're a linear pair. And then you could have done this triangle. Either way, and it would have ended up being the same number. So cool. All right, so that's the gist of your homework. So let me go ahead and assign it to you. Okay. These are B block, and this will be due tomorrow. What's today? Today's the 17th. So this will be due the 18th at 9. Okay. All right, so it should be live for you now on CUDA. Go there, 5.2. You guys are welcome to use calculators if you need to. If you're pretty fast at your algebra, you'll probably finish this with time to spare. Let me know if you are stuck. I am actually going to invite you to breakout rooms because I need to hop around. Oh, let me